Welcome everybody to these BiDS'25 lightning talks. My name is Federico Rondoni and I'm working for Starion, supporting ESA for the Earth observation programs. I'm part of the organizing committee of this conference together with Stephanie, one of the 3 co-chairs of the conference. And lightning talks that we're going to see now were introduced already in BiDS'23. They are short talks where people can talk about their work. Our first speaker is Peter Strobel from the Joint Research Center, and the next up will be Leah Kirbel from Airbus. So we invite the next speaker already to stand up because the time is very short, only 5 minutes. And when the time is over, we will start clapping and we invite the public to do the same to stop the speaker. So please, Peter, the floor is yours.
Okay, thank you. Hello, everyone. So this is about CEOS ARD. Who has heard of CEOS ARD? Okay, a few. So what is CEOS? Just briefly, CEOS is the Committee for On-Earth Observation Satellites. That's kind of the roof organization worldwide of all the major space agencies and satellite data providers, public satellite data providers. And they are working on a concept which is called analysis-ready data since about a decade in order to basically get their data together and make them easier accessible and usable primarily for you, the users. And this CEOS ARD concept is something that has over this time evolved pretty nicely. It has got a lot of acceptance. There is some of the reasons you find here why we are doing this. So interoperability, it also has become more and more a benchmark for space industry. So we have meanwhile a lot of space industry that approaches us and says, can we have our data CEOS ARD certified? Because that is kind of a quality seal that the data are being documented in a way that makes it easy to access them. That is the current suite of CEOS ARD, what we call product family specifications. They have been issued as documents on the CEOS site. They can be downloaded. They also include some instructions on how you basically benchmark your own data against them. And they're a good way of seeing basically what kind of concepts are behind this interoperability. However, time has moved on. So in the last couple of years, we found out that with the things that we have been discussing the past couple of days, AI, ML, cloud native, things are changing. We probably need to also adapt these specification. Our user base is getting broader and the expectations are getting a lot tougher. And interoperability also, meanwhile, is meaning more than just being able to stack the time series for a single satellite. People want to fuse several satellites. So it's clear that we have to move on. One of the things that we did first in order to kind of get a bit of an idea of where are we going is to make a survey, not only among the space agencies, basically everyone can participate there. So if you think you want to have a say on what CEOS ARD should look like in the future, there is a QR code here. You can participate in the survey. That it would be much appreciated. And out of that, we basically took a couple of consequences. And one of them was that we go on GitHub with our development. So far, we have done that on single documents in working groups that were working a little bit behind closed curtains. We said we're going to really open that up. We will also make it much more modular. So we will have a new kind of definition of what actually these products are and how we basically put together the individual specifications so that you really can get something tailored for each particular data set that might be the subject to this standardization. In this case, of course, we will have to make it modular. It should be much more participatory. That's why we have put it on GitHub, and it will be very closely linked with Stack. So a lot of it is metadata specifications, and of course these metadata specifications will profit from being as close as possible translatable into Stack, and this is something that we are going to do as well. So if you're interested in this, go to the CEOS page or the CEOS GitHub page. There are discussions ongoing, and participate. Thanks.
Thank you very much, Peter. Next up, we have Lea Kierbel from Airbus talking to us about purple trees. And in the waiting zone is Nikolai Adamovic. Take it away, Lea.
Okay. So, what if I told you to begin with that the Earth is a giant source of geospatial data that we want to harvest? So today we are constantly watching over, monitoring our planet with our observation satellites or space guardians which scan the Earth that they orbit. But when it comes to processing that data to explore its possibilities and extract actionable insights for decision making, things get more challenging. So we've already found a way to unlock those insights, artificial intelligence, that we've been harnessing for years to automate the extraction of information for mapping, intelligence, environment. But that's not necessarily in everyone's range to master it. So wouldn't it be more straightforward if we could simply initiate a conversation with our planet and ask directly for what we need? Sounds like science fiction? Not really. So following this idea, we can imagine a realistic scenario where generative AI opens the door to a whole new kind of interactive user experience. In fact, with no technical background needed, just the use of natural language, our words become performative, almost like spells that we cast to unveil nature's hidden secrets and conjure up new views. It's really about making visible what our human eyes cannot see. This isn't so far-fetched. In more down-to-earth terms, the magic lens is just generative AI foundation models enabling semantic search. As a result, the word is just one prompt away. You want to know if there are purple trees in Mexico City? Just type, "Find me purple trees in Mexico City," and you will discover jacaranda trees blooming there. Or sport courts, as you can see illustrated there. So, for this reason, we believe that generative AI will foster the democratization of Earth observation and help us realize just how much geospatial data matters. In fact, it's everywhere. It has already unlocked a wide range of applications across industries: mapping, navigation, location-based services, urban planning, agriculture, disaster management, defense, the list goes on. Living without this geospatial data, it would be like wandering on Earth with no compass. So it should also become another eye-opener to start taking better care of our planet, because the power to monitor and explore the planet is now right at our fingertips. So the Earth never lies, and these insights represent the best hard facts we can capture to document macro phenomena like climate change. Think about ChatGPT today, 800 million of weekly active users by 2025. Could similar services for Earth observation emerge one day? Anyone could be part of that. The simplicity of approaching such tools, it's almost childlike. Citizens, consumers could even build apps, maybe with just a prompt as a starting point. For example, show me deforestation today in South Asia. A movie producer who compared this to creating a full movie from a short synopsis, just pitching their idea, snapping their figures, and making it happen. And once again, remember that concept of performative language, words turning into so much more. So, with our eyes on Earth, let's shift paradigms. First, moving from Earth observation to Earth exploration, from an ecocentric mindset to a geo and ecocentric one, and from the mere awareness to the true mindfulness of the world around us. Thank you very much.
Our next speaker will be Nikolai Adamovic, CEO of Commercialization Reactor, and will talk about bridging science to market. Please.
Hello everyone, my name is Nikolai, and We are operator of European Space Agency Business Incubation Center here in Latvia, and our mother company, Commercialization Reactor, operator of it. But before I will start, may I ask you, hands up, who is scientist here? Pretty many. Okay, good. Second question. How many from you do you believe your scientific results could be applied into business? Good enough. Okay, we will speak about how to turn scientific excellence into deep tech startup creations. This is maybe another topic what you often do during your life, but we do it for more than 15 years, and mostly we serve for non-entrepreneurial scientists or engineers, for people who really crazy from science and do not see him or herself as entrepreneur mostly. And if it's interesting to you, let's move forward. Do you know that 9 of 10 patents still sits on the shelves? Do you know that 33% of scientific results still unvalorized? This is the answer why, normally. So, and more than 100 years ago, Albert Einstein gave us this quotation, and it's true for as better scientist is, not all of us, but as less it's interesting for him or for her to be everyday manager in company. So, normally all scientists or engineers, when I say scientists, it means also scientific engineer, let me say. We can divide for two big domains. Entrepreneurial scientists, it means a person who wants to lead the business him or herself despite skills and so on and so on. Non-entrepreneurial scientists, it's not about skills. This person can have very good entrepreneurial skills and even mindset, but he or she doesn't recognize that it's another part of life, another part of job, and understood that it's time to have somebody else. It's for us. If you feel yourself as non-entrepreneurial, or even you are entrepreneurial, but you definitely think it's not for you, at least on this life period, we can serve to you because we unite such people with entrepreneurial-minded people. It's our job. We give support and investment, and finally, deep tech startup will be created. We did it many times. We work with more than 50 plus organizations. By the way, if you are not scientists here in this audience, but you work for organizations, probably like Airbus as well, so which works with scientists. So probably among your scientists, there are people who can be part of future deep tech startup, and your organization will license IP to this new startup as well. So, and yeah, very good success stories is company Arcai. Alberta, please show you yourself. So it's a scientist from Politecnica di Torino, Italy, and entrepreneurial team from Slovenia and Latvia. So Eventech, it's Latvian leading company with it's more than 10 years old company, already mature company, leading company in Latvia, by the way, in pick a second time tagging resolution. What we do, it's completely clear. With entrepreneurs, it's much easier to create startup and pass value of death. So, by the way, we recognize as #1 in Europe program from science to capital awarded, but EIT, maybe you know, European Institute of Innovation and Technologies, and the Deep Tech Talent Initiatives. So, after a little bit more than an hour, in room number 4, there will be 1.5 hour good workshop, and very welcome to all of you to be there to understand more precisely what does it mean commercialization, some very cool tool how to help yourself to understand where your uniqueness and where your championship lies, and so on. But if you scan QR code, you always can approach us, and probably after some time, after a year or maybe less, maybe more, some of you will apply also to SABIC, and we will manage at least more than 3 years here in Latvia. And Lev, he is director of SABIC. Please approach him as well. And probably you will become a resident of SABIC, as Dr. Alberta and his team recently awarded. Thank you very much.
Thank you very much, Nikolai. Next up is Johannes Uhl telling us about global highway networks. And in the waiting zone, we have Kwon Lee. Thank you, Johannes.
Thank you. Hi, everyone. So let's take a look at this image here. So this is a suburb of Lisbon, Portugal, and we see some water in the back, but we mainly see the built environment, right? And what Earth observation can tell us about the built environment is a lot, right? With Earth observation, we can, for example, identify where buildings are. We can identify the shape of buildings. We can also estimate and measure the height of buildings. We can also estimate the age of construction year of buildings, and we can estimate the use or the function of buildings, such as residential buildings or non-residential buildings that could be commercially or industrially used buildings. We can also come up with typologies and classifications of the built environment, like this one here. Or we can use Earth observation data integrated with other information to estimate the population, the number of residents in a given aerial unit, such as a grid cell. Of course, we have information on the road network from OpenStreetMap, other sources, remote sensing as well. And we can, measure and model, for example, accessibility to services. We can do travel time analyses. We can use this information then to model, for example, commuting patterns and flows, which again can be used to model, for example, the urban influence area of a given city, right? We can also use highway network data, for example, to model patterns of trade and other traffic-related or commerce-related phenomena, right? Now, often we want to do such analyses over time because we want to measure sustainable development, for example. And one shortcoming is that we have surprisingly little information about the temporal component of highway networks, right? So in many countries, we may have data on highways, but we don't know how the highway network looked like in 1990 or the year 2000, right? And because of this, we are working on a model or a framework that aims to backdate highway network data by integrating OSM highway data and historical Landsat observations in order to tackle this shortcoming, right? We want to be able to do accessibility and connectivity models over time, but we're impeded by this lack of data. Yeah, and it's a relatively simple method. It's still in its infancy, but we have a poster about that. And if you're curious, then come see me after this session at the poster booth. Thank you very much.
Thank you, Johannes. We are looking forward to see your poster later at 5:30 at the poster session. And now we have Kwan Lee that will talk about mangrove distribution on the Mekong Delta. And the next one on the waiting zone is Georgios Ozounis.
Sorry, how's the play? Sorry, I don't see. Okay. Yeah. Hello. So, yeah. So this work is from our project AI for mangrove blue carbon in Vietnam. It's funded by Research Island in ISS, and we work with a partner in Vietnam. Yeah, so the challenge that we have here is Vietnam has a large area of mangrove which offer multiple ecosystem services. However, we are losing a lot of mangrove over time, and the government don't have up-to-date mangrove information to focus their conservation effort. So in our project, we aim to use AI to provide low maintenance, validated and up-to-date mangrove forest information for the Vietnam. And yeah, so we started by creating a large set of mangrove label, which we use to train our AI model. In this project, we collaborate with Global Mangrove Watch, which is an organization which create map of mangrove at the global level, and they showed us a map of mangrove habitats where potentially there will be mangrove along the coastline. Based on this mangrove habitat mask, we select 3 areas of interest in the south of Vietnam, the Mekong Delta, where there are like 70%, about 70% of Vietnam mangrove located. And we generate, our area of interest covers 6,500 square kilometers. Yeah, so for our label generation protocol, yeah, we generate different type of data layer for our annotator to look at and draw the mangrove label in the polygon vector format. We have 2 stage labeling pipeline. So in the first stage, we have like 24 trained annotator, look at the layer, data layer, and manually draw the mangrove extent label as vector. But obviously there's an issue with this because there are lots of ambiguity, and usually annotator will like have their own individual bias. So we also create another version of label where we have another map expert to re-annotate the same region. And then you have a member for panel 4 member to look at the 2 versions of the label and educate on the discrepancy to generate a version 2 of our label. Yeah, so this is the feature we choose to train our model. We use standard 2. The set has 62 million pixels. Split them into train validation test. We use the large GBM model to train two models, one on the label version 1 and another one on label version 2. For evaluation protocol, we use precision and actually calculate the macro average F1 score, which is based on precision and recall, because our data set is highly unbiased, like 80% of the data are non-mangrove and only like 20 are mangrove. And then in addition, our partner from Global Mangrove Watch also provide us an independent data set, which include 19,688 reference points. Yeah, so the result is that the macro average F1 accuracy on for our first model is 87.3%. Once we have in the version 2, the accuracy increased 4.6% to 91.9 macro average F1 score. And also we validate our final model with the data set provided by Global Mangalwatch, and we got very high accuracy, nearly 100%. So actually, the performance of our predicted map is higher than the performance of the current version of Global Mangalwatch version 4. But obviously, our map is created only for the Vietnam, and with the help with the local experts, or Global Mangalwatch is a map at the global level. Yeah, so some discussions. Yeah, so when you have the label version 2 reuse noise at the quick edge and mixed aquaculture battery, where easily single annotator will make mistake. Also another thing we noticed is that Global Mangalwatch point cluster are usually in the dense core of the mangrove. So the point F1 score that we achieve on that set overestimate the accuracy at the boundary of the mangrove forest. And also another issue we see is that the sensor co-registration offset between Sentinel-2 imagery and NICP imagery introduce noise into our label, because our annotator make mistake when they see that the signals are not clear. And future work. Thank you.
Thank you very much, Kwon. Next up, we have Georges to tell us more about the Atlas of Human Settlements. And in the waiting zone, we have Tobias Reiger-Stachel.
Hi all. This is a brief overview of our featured product, the Atlas of Human Settlements. The Atlas of Human Settlements can be thought of as the commercial grade equivalent to the global human settlement layer produced by the European Commission. So it is a layer indeed delivered at 10 meters spatial resolution. It has global coverage. We have historical records that cover the past 10 years. And under our tier program, we actually produce this on a monthly basis. The features of this product are as follows. So first of all, we have extremely high precision and recall in detecting build-up. We are regressing the input data, and we're finding the percentage of built surface within a spatial unit of 100 square meters. The other perhaps discriminant feature is the fact that we are producing stunning visual clarity. So by contrast to other layers of the kind, you can see the individual buildings in our results, despite the fact that when looking at the source data, the Sentinel data, with the naked eye, you cannot really see the buildings themselves. And we deliver things in an actionable form, meaning not only just raster, but also vector representations of the built-up. Use cases, well, pretty much everything involving urban monitoring and urban planning, smart cities, supply chain and logistics is among our core strengths, let's say, defense and security, and crisis mapping. So here you see a preview of New York and New Jersey area. It's a zoom out, and as I zoom further in, you can see some level of detail showing up. That's Manhattan, going to the east of Brooklyn, and lastly to the Hamptons. So this is just the top level view. The more you zoom in, obviously you have a better clarity of the results. But talking about clarity, here is an example of map data, our detections in vector format, and the detections themselves superimposed on very high resolution satellite imagery. Doing this systematically allows us obviously to do change detection and very high accuracy in change detection. So here you see the Southeast Corridor in Georgia, United States, and in blue you see the buildings that do not exhibit any change. In green you see the new additions, and in red the new building removal. Zooming in, you can see a new construction project, a neighborhood that was constructed in that area. And you can see on the preview window that we have our detection superimposed once again with the very high resolution base map. What is very interesting to see is that in the case of the public map APIs, most often this information is not updated in real time, meaning that, you know, this image that you see, the VHR, is a 2024 image. The map is just a few months back, and still that information is not imprinted there. So for every detection, we can actually report the construction date for that building. We can report a whole lot of attributes that are important to the customer. And just as we do the construction, I mentioned before that we do the demolition or destruction of buildings. This is another feature that most maps fail to cope with, meaning that, you know, their mapping companies are very good at adding data. They're very bad at removing data. So buildings get removed as well. And not everybody's good at catching up with that. And lastly, I mentioned before, or I showed before, New York, which for some people, this is an easy case. Well, we handle everything from massive warehouse buildings that you can see in California, 200,000 square meters in surface area, all the way to mud huts in Africa. We find every single building on the planet and report it with high precision. Thank you all very much. I have a poster in the poster session right after this. We'll be happy to walk you through that. Thank you.
Thank you, Georgios. Now we have Tobias talking about Global Food Monitoring Service, and the next one in the waiting zone will be Veronica Mercuri. Thank you.
Hello everyone, my name is Tobias. I'm working with EUDC, the Earth Observation Data Center, and we are based in Vienna. And we are part of a consortium, as you can see here, of those very nice and beautiful logos, and we implemented and are running the global flood monitoring. So what is it? The key aspect of global flood monitoring is that we provide near real-time flood map provision within 8 hours after Sentinel-1 data acquisition. That means that we process every Sentinel-1 scene which is acquired in GRD and are running then the flood mapping algorithms and then provide the data to the users. And how do the users get to the data is we integrated a set of APIs and a set of user interfaces, and the most important one is the emergency management system, the Copernicus Emergency Management Service. So namely it's EFAS, the European Flood Awareness System, and also GLOFAS, the Global Flood Awareness System. Coming from Sentinel-1, we have a 20-meter pixel sampling, so very high spatial resolution, a global coverage because we process every Sentinel-1 scene, and we also process the whole archive, so all the data what we got from Sentinel-1 so far, from 2015 to ongoing. So how do we do this? This is the basic workflow. So at first, we get the data through Copernicus Data Space Ecosystem. We download the scene, and then one big part is the Sentinel-1 Sigma 0 pre-processing. This is then registered in a Sentinel-1 Sigma 0 data cube, and this is the basis for, in total, 5 floods or 5 algorithms. We have 3 individual flood algorithms, which is the one from LIST, Luxembourg Institute of Science and Technology, the one from TU Vienna, and a third one from DLR. And those 3 are the inputs of the ensemble flood mapping algorithm, which is a combination of those 3. Additional to that, we also have advisory flagging to give you more information about the outputs. And of course, we have some offline processed auxiliary data sets. And the output of all of this is cloud-optimized geotiffs, and also they are registered in our UDC stack catalog. So to do that, we have a set of software and a set of hardware, of course, which this is processed on. We are using OpenStack, Terraform, Ansible, so all the established software frameworks. And our main component is basically the Apache Airflow orchestration. And what I want to highlight is that we process everything, or we provide everything, or all the output layers as stack items. We heard stack quite a lot the last few days, but it is a very good specification, very good standard to describe the metadata of such huge big data sets. To access the data through Stack, this is publicly available. Just go on or just Google global flood monitoring, or meet me then out there at the poster sessions how to access it. But it's publicly available, and you can start downloading the data, or you can also integrate it in your existing workflows, or you can also come to us at EDC and create your workflows on our Jupyter Hub, which is then directly linked to our DAS gateway to create some DAS clusters. And that, of course, is again connected to our storage where the data is lying around and up for you to process with. So thank you very much. Meet you out there at the poster session.
Thank you very much. So next we have Veronica talking to us about unlocking the power of big data and Earth observation, very fitting to this conference. Next up is Shoaib Burg from Decision Labs.
Good morning, everyone. I'm Veronica Mercuri, Associate Scientist at EO59. And today, I'd like to take you on a journey through radar data and into the heart of our moving Earth. We live in a world that's constantly changing, often silently. The ground sink, structure shift, mountain breathe, and we have the right to listen to it. So SARPROTS is a tool that can help us to do it. SARPROTS was designed to processing Sentinel-1 data and give the chance, it's like a lens, a voice, a key to understand what satellites are telling us. SARPROTS can handle a huge amount of data, a massive volume of satellite data. We are talking about big data, terabyte of radar images collected over time, telling stories of geology, cities, and climate. And what you can do with those data, you can query them, filter them, analyze them, and make statistics on them. That allows you to understand the inside of your case of study. So these are a few examples, because with SARPROTS you can work on a small area and big area, and you can work on big scale or small scale. To your right side, there is an example of New York City. You can also make change detection analysis for city planning, disaster response, infrastructure monitoring, and environmental studies. So here an example, we have first images, amplitude images, taking in a different time than the second one. And what you can do by making the difference of the two amplitude images, you can detect the change detection that allow you to understand what have changed between the two images. Also, you can make interferograms to detect ground deformation at any scale and to understand the change in the topography and the atmosphere. So what struck me most is it's not only user-friendly with an intuitive graphic interface, but it's the ability to democratize science. So EO59 offer free license for students and PhD research. This isn't advertising, it's an ethical choice because we wanna know that we wanna share knowledge and we wanna that knowledge are accessible and shared to everyone. So in conclusion, SARPROS is not just a software, it's an invitation to observe, to understand and to protect the world where we live. In a world that moves, having tools that help us read the change isn't useful, it's urgent. Thank you for your attention.
Thank you, Veronica. Now we have Sohaib Burk, who will talk about GeoJS, bridging Earth observation AI to the browser with web GPU. And we'll also have another talk after this one, so please, the floor is yours.
Okay, sorry. So I'm Shoaib. For the people in the front row, I'm a green box. I think only 2 people got that joke. So I'll be talking about GeoAI.js. And essentially, you would know that a lot of times you're seeing all these cool demos of visualizations. Yeah, you're wondering, like, this is really happening, like, this must be really complex, and there must be, like, huge amount of technology and supercomputing going on behind it. What you're seeing here is a drone image which is being displayed with embeddings from a vision model called Dino version 3 from Meta. And I am showing here by hovering over the map which areas are similar. So that's your classic embeddings, right? The keynote was about that, and we all are familiar with embeddings now. But in this case, I'm running it all in the browser. There's no backend. It's just running on some imagery that is in my, for coming in from a tile server, just like Google Maps and it's just, I'm able to just do this. And how am I able to do this is because we created this open source library called GeoAI.js, which already supports a bunch of tasks for doing satellite and remote sensing analysis, things like object detection, classification, segmentation, and some advanced tasks. These are some of the tasks that are already there. And you can see in the object detection, we have everything from detecting cars to solar panels. In segmentation, we have wetland detection to building footprints, and then some advanced tasks, things like zero-shot object detection, as well as segmentation, actually, and then image feature extraction. People might not be familiar with those terms, but I'll touch on those quickly. So the reason we're doing this is because I feel like there's a whole bunch of developers that build amazing tools in JavaScript, but they have no way to actually express themselves. And so, because a lot of it is done using Python or in complex cloud infrastructure, and we just wanted to get the power of GPUs that are web GPU into the hands of people who want to build geospatial apps. So the way we did it is that we are able to just extend existing tools that we already love and use, like Leaflet and DeckGL and MapLibre for the client side, and then you just add include our library or the open source GeoAI.js library, and then get access to your whatever imagery you're accessing, and then run it. Here's another demo. Here's the segmentation task. This is the car detection, and this is the ship detection. This is the solar. Some music would be nice. This is the wetlands, and this is zero shot. Zero shot is just when you do, zero shot just means like if you have an image and it's not trained on any labels in that particular class, but you still give it some text and it's still able to find it. That's one of the powers of sort of these larger models. So how does it work under the hood? So what we're doing is something called model quantization and using something called transformer.js, which is an open source library from Hugging Face. What it allows us to do is take a model and run it through this process of converting it to something called ONNX. ONNX is like a universal a method of sharing models. Like it's basically a standard, interoperable standard for AI models. And run some quantization which compresses the model so it can run in the browser. And then you just include it in the code, and then this is importing our library, the GeoAI.js library, which, by the way, I should mention is MIT licensed. I keep saying my library; it's a community library. Yeah, you say which provider you're using, and then you just pass in your parameters to do the detection, and it comes back, and then you can just include it and create HTML apps. You can even email it to somebody, and they can open it and run AI. And what are the benefits? Like the key benefits are really obvious. Like you don't need any complex infrastructure. Some of the models are based on YOLO backbone, which means you can even deploy them to cameras or drones and edge devices. They can do real-time object detection. Yeah, and the data stays in the browser. You don't have to share it with anybody in the backend server. Yeah, simply, if you're a JavaScript developer, you'd be familiar with this. If you're not, yeah. And here are some of the links to the, yeah, I should have had a QR code, but feel free to take a picture.
Okay, thank you. So you can stay on stage for your second talk on how agentic AI works. And in the waiting zone, we have Lazaro Alonso.
Okay, long time no see. Okay, so I want to talk about another thing that I've been thinking a lot about lately, which is agents, AI agents. Everybody wants to talk about agents nowadays. And in this talk, I just wanted to kind of like set the scene for us to, as a community, start coming up with ways to have a common language around agents for Earth observation work. And to do that, I just want to start by introducing the vocabulary that is currently in play in the industry. So if you're here and you don't know about agents, this is a really great way, just like quick primer of what agents are. And then we'll talk about like agents in the Earth observation context. And this came about, the backstory of this is that, we built this thing called EarthGPT, which is really a way to test the idea of this, talking to satellite imagery. We built this tool. It's live, you can try it out, earthgpt.app. But so over the next few minutes, I'll be talking about some new concepts: tools, agents, workflows, memory, evals. Okay, what are they? So what is an agent? Agent is essentially 4 things. 3 if you want to be really simple. Could even be 2, but 4 if you want to be really complete. Some agents only have 2 things. So you have to have an LLM. You have to have a language model that the agent has a way to understand language and generate language. And then you need a toolbox, because the agent needs to have agency to do things, and so you need to give it the tools to be able to do things. And tools are just the functions and libraries that access or do things on your behalf. And then there is something called memory. Memory, as you can imagine, is just ability to hold on to information in the short term so that it can refer to it later as it's having a conversation or doing something. And then finally, evals. Evals are very interesting. Evals are kind of like the, you know how we sometimes think of things and then we're like, should I say it out loud or not? You know that thing, like a filter? Well, some people have it. That is like eval. The eval is basically telling the agent before it gives you the answer, it's like another check, it evaluates whether the answer is correct. And so it's a way to prevent hallucinations and things like that. And then there's something called multi-agent, and this is some examples of multi-agent topologies. Multi-agent topologies are where agents there's like agents of agents. Agents can have, have supervisor agents, which can delegate tasks to other agents. You can have hierarchical agents, you have custom. Anyway, so you see sort of typical topologies of agents. So here I am in Riga, and I am, I would love to go out for a walk and see some places, and I also want to know what I should wear. And obviously, I'd like an agent to answer this for me. What does it need? What are the tools it needs? So if you think about it, it needs some tools, and this might be its toolbox. It could be that it needs to know where is Riga, so it can have a geocoder. It needs to know the weather. It needs to have some way of accessing weather APIs. It needs to know what are the attractions and points of interest in Riga that might be interesting to a tourist like me. And finally, it might need to know how to create an itinerary in some sort of a meaningful way. And then finally, it needs to be able to know in what order to call these functions. So obviously, it cannot go and check the weather unless it already knows where Riga is through geocoding. So it has to geocode first before doing the weather. So that is what the agent has to be able to do, and that's what it does. I mean, most agents are designed to do that. Now let's talk about Earth observation. In Earth observation, we're running out of time. Here are some tools that I've already started putting together, but my end point is to get to a point where we have workflows for our community. We have workflows for like useful use cases in the Earth observation. So I'd love to have a discussion and working group going. You can take a picture of that if you're interested in starting something up, a conversation in Earth observation related agents. And then we can follow up and set up something as a community to discuss agents. Thank you.
Thank you very much. We invite to the stage Lazzaro to talk about what would you do if you could have a simple into your data. And the next one will be James O'Connor. Please.
Yes, what a day. What would you do if you could have a glimpse into your data without installing anything? And that's, like the previous speaker said, let's only use a browser. Yes, only a browser. So that means no more complicated setups, okay? But also means no more login, subscribe, and filling in some data. So today, I'm really excited about browser.io. So what is browser.io? It's a browser-based visualization toolkit for exploring and analyzing SAR data stores. So we provide some curated data sets in which you can see how browser.io works. You can explore from animations, changing the plot types into a volumetric plot, so that you can not only explore the spatial variations, but also in time. You can have the normal planes, but you can also have point clouds in your browser. You can have a lot of settings there so that you can explore your data in more depth. And you can even select pixel-wise data in any dimension with further insights into your data. But we didn't stop here. We incorporated web GPU analytics to bring up performance to the users. So that means that in your browser, you can apply operations such as this 3D kernel, or a bunch of more functions that you can explore there. Please go there and try. But what about you? I'd say, at the beginning I said, you don't need anything else, right? So for you, if your source store is already public, just copy-paste it, click fetch, and start exploring your data set. Oh, you're not ready to share your data yet, or ever. We got you. Come here, select your local file, and start exploring your data. Oh, probably it's not working, right? Well, we are truly open source. So please, if you find bugs, report them, open issues, or even better, contribute with code, and open a pull request. That was browser.io. Thank you.
Thank you very much, Lazaro. Next up, we have James O'Connor, and in the waiting zone is Mohammed. Just for everyone to know, we are more efficient than we were planning to be. So in case there's somebody else who would like to have a little chat or tell us their favorite spacey joke, we're ready for that. Okay. Floor is yours.
Thank you very much. Thanks to the chairs, to the organizers. What an amazing event. And to the Latvians in the room, paldies. Hopefully I pronounced that okay. Oh, sorry, skip forward a slide. My objectives today, in the 5 minutes I have, is to describe SatView, the business, and kind of some thoughts around foundation models as a new data provider in the commercial Earth observation space. So SatView are a Copernicus contributing mission. That's the mechanism whereby ESA provision commercial data to augment the Copernicus program, as well as an ESA third-party mission. So for researchers in the room, you can access some of the data that I'll show through that mechanism, free for non-commercial use. Without further ado, I'm just going to show a HotSat product. HotSats are the satellite platforms that capture our data. And so a couple of things to note here. First of all, it's a video, so that's one of the aspects of HotSat data. And second of all, this is taken in the middle of the night. So what we're looking at here is mid-wave infrared imagery, and what we're offering is basically a higher spatial resolution by an order of magnitude over anyone else in the market, as well as in the kind of public domain. Just going to play that once more. Yeah, so as you can see, there's a compass in the bottom left here. The satellite's passing from the southeast to the northeast overhead, and it's in spotlight mode, staring on a target on the ground. And I just have an inset box here showing that we can see some moving heavy goods vehicles as they travel along the track. We've put a lot of effort. I've taken this slide from a calibration conference that we attend. We've put a lot of effort and research into making sure that the corrections and calibration are as accurate as possible. We're working with CLSARD. We heard from Peter earlier about how we're trying to contribute to that initiative. Okay, so just to emphasize the dual-use nature of our technology, in the left here I'm showing an image from Yokohama Harbor in Japan. And so what we're seeing basically is some of the water dynamics as outflows from industrial processes hit the port. And so we believe there's a really strong use case here for environmental monitoring of not only estuarine water bodies, but inland water bodies, particularly those next to outflows for industrial plants, because we can image this at a much higher resolution than's previously been accessible. On the kind of intelligence side, or strategic intelligence, something that SatSen might be interested in, we're imaging here 8 gas-powered turbines. And we can see immediately from the HotSat imagery that 7 of the 8 are active. You're going to have to trust me that there is 8 of them. But the 3 to the north are running at a higher temperature than those to the south. So this kind of insight is something that's kind of not been accessible previously from space-based instruments. So we're excited to bring this to market and to the scientific community more widely. I think I wanted to touch on, we're consumers of big data. I mean, we saw the Czar presentation just previous to me. We use ECMWF atmospheric forecasts to do calibration and kind of account for atmospheric conditions in our imagery. We use Sentinel-2 and the global reference image as a particular product that gives us very accurate mapping. We use the Copernicus DEM, land use land cover maps, to name but a few products. But really, when we look into the future, and the near future, these foundation models are exploding in terms of their scope. I've just highlighted a couple that we're aware of. For example, this NVIDIA Cosmos framework, it's mainly, the idea is mainly that it's used on edge computing for robotics applications. But for us, if we can do this kind of thing on board, represents good opportunity for compression. In the keynote, in the first session of the conference, we heard from Thomas from IBM introducing this TerraMind, as well as other foundation models like Copernicus foundation model, kind of learning from the corpus of Copernicus data, but in both of these cases, our data is very out of sample. So there's kind of a risk, but also an opportunity here for us and for everyone in the audience to try and explore a bit more about how we can potentially be used as validation that these foundation models are kind of based on physical principles, and at the same time kind of develop applications off the back of this. So that is 5 minutes, and thank you very much again.
Thank you. So now the last speaker will be Mohamed Sabi Fouda from Salutz. I think he's having some technical issues uploading the presentation, so we might wait 1 minute.
Okay. While we wait, anybody has thought about a space joke they want to tell us? Not really? Okay. Here we go.
Now we miss the speaker, though. I think he's coming.
So maybe while we wait, Salutz won the 2nd place of the BiDS award. So we're actually looking forward to hearing their pitch very much. Awesome, thank you very much.
Hello everyone, this is Mohammed Subhi from Salutz. We build an AI platform for autonomous operations in space and on Earth. Space and Earth operations are constrained by power, latency, and fragility. We are building an AI infrastructure for space and Earth to make the operations autonomous, efficient, and sustainable. Our solution comes as a dual strategy, software and hardware. Our hardware is already patented, offering 10 times lower in power consumption and edge computing for satellites, drones, and ground robotics. Our software, offering a chat-based interface, secure and reliable with quantum processors, and offering a seamless, simplified operations for complex systems like satellites, ground stations, and data analytics. You can see here now how easy you can integrate your satellite systems to our platform and get access to our distributed ground stations through us and our partners all over the planet. So here you can see an example of a user trying to get vegetation analytics for Salt Lake City in the United States. Now, on the side here, you can see the user can easily map their area on the planet, and it goes also on a full screen mode. And in a few milliseconds, you get an actionable intelligence in this PDF form inside the platform, or you can download it or have it in your email or send it to your end users. We also have other features like trees counting and feature of going back to the history, comparing object detections between the past and the future, construction and deconstruction monitoring, leakage and oil and gas leakage in the oceans and sea. And we have also like algae and seaweed management and monitoring systems. And we are partnering with more analytics companies to offer more and more features to enable it through our platform to the end users. We are the first in the industry to integrate a seamless operations with quantum processing units. And here in this example, you can see how with our quantum computing processing, you can get a seamless pattern extraction with our platform, enabling a next era of analytics and optimizations. Further, we offer cloud storage, project management, and satellite job scheduling for future recurring job, and also custom dates management for going back or going forward in the history. Whether you have a satellite or only you need the data, by integrating in our service, you get a seamless, simplified operations in the fingertips with all intelligence. We're also offering enablement to the small companies, SMEs in the ecosystem and mid-size by giving them a full portal for offering their services as well through our platform. So whether you are the end user or another startup having service or product, you want to offer them to the space ecosystem, by integrating with us, we are enabling you and offering you more further features to get more visibility in the industry. As you can see that, as I said, we are 10 times in lower power consumption when it comes to edge computing. We are 20 times more data can be processed using our simplified operations autonomously, and we are decentralized on the cloud chain in space and on Earth. Great features, especially for the governmental and information security, that our system can be deployed also 100% offline. Of course, it comes with extra costs. And as you can see, what can be done in hours with our system can get down to minutes or seconds. We see a great market in front of us with over 15 billion only about AI in space market. We have identified 3 ideal customers today, and we got already our 3 paid pilots with them. Nevertheless, our path is to expand to different markets like the defense, the disaster management, and logistics. Here is a roadmap of further customers highlighting the current target. We have already got awarded the Business Incubation Center with the European Space Agency in Bavaria. We got the Space for Defense and Security from the Cassini program, Cassini initiatives, and we got awarded Economics of the Future in 2024 and High Tech Ventures 2025, and we got the second award today in BiDS award here, Big Data from Space with the European Space Agency and the partners with Airbus and Altair. So we have a great team of expertise. So please join us to a journey to a future of secure, reliable, and autonomous space operations. Thank you very much.
Thank you very much, and congratulations for the award. We also heard that there is one more volunteer. Is this correct? Yes, awesome. So this is the beauty about lightning talks. Whoever would like to pitch for 4 minutes is welcome to.
Thank you.
Thank you. Okay, so next up we have Carl Pucci from EO59. The floor is yours.
So what's up, everybody? You had my fantastic staffer, Veronica, here earlier talking about all the coolness of SAR Pros and how you can use our software to make InSAR work for you. But we're gonna do something a little bit different, but I'm waiting for the signal that my slides have arrived. And when they have arrived, there's a special little boom for you in the scientific community. So I promise the boom is worth the wait, so to speak. So in the meanwhile, I'll tell you a bunch of dorky scientific stuff. So let's say we have Sentinel-1, here in the beautiful ESA universe. It's doing two different things. We all use it for basically running optical processing on SAR data, which is super lame. And so we do phase processing on SAR data, way cooler, how much stuff is moving, like this building and your house. And then we sell that information at our company to end users in the United States because it's a lot easier to do business in America than in Europe. So we're like the weirdest company here because we've accepted no money from ESA or anyone at the European Union because it's so annoying. So instead of taking any money from the EU or ESA, we just took the data and sold it to people in the United States. And we employ people in Europe, which is kind of fun. And we get a lot of cool high-tech shenanigans from here, thanks to ESA funding, which is very good. Thank you for your high-tech shenanigans. But you know, one of us, good parts of us crazy Americans is that we can talk forever about nothing while we wait for our slides. I'm looking at you back there. How many minutes are you thinking? 2. All right, 1.
You know, we're still waiting for this spacey joke.
This spacey joke. Oh, put me on the spot here, a spacey joke. I had my AI create jokes about INSAR, but I don't remember what they were. And thank God, now my slides have arrived. All right, are you ready for this, everybody? Stand up, all of you. Let's go now. I'm not gonna let you go. Stand up. Let's go. Stand up. Up. Come on, stand up. Now, you in the brown sweater. And you with the gray hair. And you with the glasses. And you with the lanyard back there. I'm looking at you with the lanyard and the glasses and the gray sweater. That's you, baby. Come on, let's go. Up. Let's go. I'm looking right at you. I'm not gonna stop until you get up. Let's go. You in the white shirt and the laptop. You with the blue shirt. You got no hair, man. I can see you. I know. I mean, that's not a bad thing. Come on, let's go. Up. You can do it. You're a devilishly handsome man. Up. I'll do it when you stand up. I'll stop. You're the last guy. Come on. Oh, the laptop. Oh, come on. Can you give me a little butt wiggle? Can you do a butt wiggle? I didn't even get a butt wiggle from the bald guy. It's okay. We are all entrepreneurs. This is the thing that we all forget. We're all trying to figure out how to get across the road. We're all here, like the chicken or the boys trying to steal pizza from their sister, to get a mission across a line, right? We've got ideas, we've got software, we've got ZAR and Python. But why are we here? Why are you in this room? Why are you playing with spaceships? Because you have a dream to do something spectacular. And your whole challenge is how do you communicate it? Because we all see things differently. And that's our superpower. The superpower among everybody here is that each of us can imagine a different world than someone else. So I want you to do something else. And the bald man can do this. Close your eyes. Close your eyes. Stop looking at that laptop and close your eyes. Okay, now picture a red apple. Okay? You too, Airbus girl, eyes closed. All right, now open your eyes. Now I want you, Federico, to tell me what you saw. With your eyes open, baby. What did you see, Federico?
A red apple.
Describe it.
Black space, apple in the middle, red.
Stephanie, what did you see?
A red hat.
See? She saw a red hat. I've asked this question in countless audiences around the world, and I've gotten people who say they see nothing. People see red hats. Some people see green apples, even though you tell them to see a red apple. Some people refuse to stand up. Other people's, they dance like wackos. The thing is that each of us thinks that everyone else is seeing the world as we see it. Like you think, you must be seeing the red hat because I'm seeing the red hat. But the truth is that difference in perspective is why preaching about ZAR or preaching about synthetic aperture radar or preaching about whatever it is we're here to preach about matters, because none of us is seeing it the way you're seeing it in your head. And the other cool part is that each of you is from someplace weird, right? Latvia. I mean, in America, we don't even know where Latvia is. We think it's a city in Indiana. And I'm American. And, we shouldn't be given the right to basically have toys anymore because we're so crazy these days. Case in point, We were born global. Each of us here has a chance to change the world. I now live in Estonia. Any Estonians in the room? Woo! Tere tulemast. So, Estonia, a little country like Latvia, people from all over the world. I came from the United States there. I grew up in a bunch of places that are like the middle of nowhere. And then I ended up working at the White House from a really terrible town. So what do I do? What do you do? What's that thing that brought you to your story? Well, I was the dude with big dreams. I was like the kid that kept going to air shows and wanted to watch Star Trek all day. But the thing that really changes the world is love. It's love. I met this beautiful Estonian young lady and changed the world for me. I moved to Estonia. And when I moved to Estonia, I had a degree in political science, not in physics. And when I got there, I found the European Space Agency, and Estonia had just joined it. And I had a background of working at the White House, the Obama White House, back when it was still somewhat sane. And I had worked at the UN, and I still didn't know what the hell I was doing, but I was super duper enthusiastic. Literally, I would fly in helicopters because I met pilots in saunas and do all kinds of crazy stuff. But you might be going, meh, I don't care. But the truth is, each of you has identified a need. Each of you has found something that the world needs, and you've had a dream, like me with EO59. You've had inspiration, whether it's children or the fact that you want to eat ice cream for breakfast every day. All of you have a kick-ass team, and then all of you found this. We all found some spinning orbital jazz that you can do something cool with. And then you brought it to life, like that.
740 is your time now. Well, it is the fastest highway in the nation, and its caretakers are going to space to take care of it. I had a chance to speak with the team overseeing SH-130.
Dad, can you tell us about this new technology that you and your team are using on SH-130 that measures ground movement on the road?
The soil here in Texas is what's referred to as heavy soil. It has a high clay content. And so the soil tends to expand and contract, and that can affect the roadways. Satellites fly over the location of the road about twice a month, and they take images. And what we're able to do is to take those images and identify certain points on the roadway. We have 30,000 of them, and we measure how much those points move every time the satellite flies over. We want to monitor that so that we get a head start on any maintenance that needs to be done in connection with that movement.
That's today. That's why we're all here, right? We're here to serve a client, to serve a need, to do predictive maintenance. That's why we take the widgets ESA funded you to build and we sell it in the United States. But it all came from somewhere, right? It came from launching spaceships in Couve, French Guiana. Very, very cool. Never forget how cool it is, but it comes from further back.
Secure our nation's interests in, from, and to space.
You see, the thing that none of us want to admit is that we have to thank the military for the reason any of this stuff exists in the first place. They're the ones who put it up there back in the 60s. It started with this guy. Now we're in the civilian side of it, but not even that guy. It started with that one, the Bond who had the sexy voice. And in the radar world, he had to solve a big problem. Stephanie, what's the problem with this image if you're James Bond?
It only shows a part of the world, maybe?
It shows only a part of the world, and that part of the world is covered in clouds. So if you're trying to see Soviets moving stuff around and it looks like that, you're toast. Today, we take stuff for granted, like Google Earth, where you can literally see hardened aircraft shelters in different countries. And in the past, it was impossible.
People have always thought that big ideas were impossible until we made them come true. Finding new ways to innovate, helping humanity prepare for the unpredictable on the planet we call home. We see from the perspective of stars. push beyond to keep the world safe.
We've all heard of the CIA or MI6, but you may not have heard of those people. The National Reconnaissance Office owns all of America's spooky spaceships. Why the hell would those spooky people make a video promoting their spookiness? Because they are just like the entrepreneurs that you are who got up and started dancing. They want to be heard. They want to communicate. They need to recruit you to go and invent a future, to keep the world safer. Something that I challenge all of you in this room to do is to figure out how to better communicate. How do you reach the world with your message? How do you reach the students at the University of Latvia to know why you do what you do and inspire them to come and work with you? To take a dream like this, which was a radar array glued to the side of a Minuteman missile in 1962. It was launched into space with its mission canceled 2 days later. It's called Quill. It was only declassified in 2012. And America never had a publicly acknowledged SAR satellite since then, since 1962. But it took some random dreamer, whose name was also Carl, who worked for Goodyear Tire Corporation, to go from that to that. And that's why anyone who works in SAR has a bright future today, because you can use Sentinel-1 for the biggest source of open source intelligence information the world has ever seen. It's one of the reasons Sentinel-1B was killed. So I truly believe that each of you has the ability to bring something special to the world. I am so pleased I had a chance to jump up here on the stage and get you dancing and torture the bald man. And I hope to God that you have a great party tonight, network your little butts off, and if you're interested in playing around with synthetic aperture radar, come find me, and I'll promise it won't be boring.
Thank you very much, Carl, for bringing the international and American vibes up here, and for volunteering for communication lessons for others.